Greetings, fellow Rustaceans. We are back with another episode of This Week in Rust on the Rustacean Station. As always, I'm Nell Shamrell-Harrington, lead editor of This Week in Rust, and also a senior staff research engineer on the Rust team at Mozilla. This episode covers issue number 350 of This Week in Rust, published on August 4th, 2020. We are continuing with dividing our news and blog post sections into subsections. Thank you to all who expressed your feedback on Reddit and Twitter. It seems you really like the subheadings, and we are going to continue to do them. Additionally, I'm going to do something special on this podcast for the next few weeks. RustConf is coming up on Thursday, August 20th. I'm emceeing the conference, and I'm getting ready by interviewing the upcoming RustConf speakers. Each interview is 5 to 10 minutes long, and we'll start off this week with Siân Griffin, Jane Lusby, and Ashley Hauck. Each speaker will introduce themselves and give you a brief preview of their talk at the end of this episode. First, the news. In official announcements, we had not one but two new versions of Rust released this week. Rust 1.45.1 is a collection of fixes. It addresses bugs that only affected the 1.45.0 release. Rust 1.45.2 is also a collection of fixes, one fix for 1.45.1 and one for 1.45.0. Check out the blog post for more information. Moving on to tooling, I'd like to highlight a new project called Headcrab, which just published its July 2020 progress report. Headcrab, which I've mentioned on this podcast before, is a project to create a new modular and composable debugger library for Rust. This project looks very promising, and I encourage you to check it out and get involved. Next, a new section of the newsletter called Newsletters. While This Week in Rust provides a general overview of what's going on with the Rust language and in the Rust community, there are several specialized newsletters that focus specifically on things like Rust game dev, Rust and blockchain, and as featured this week, Rust OS dev. This month in Rust OS dev provides a regular overview of notable changes in the Rust operating system development ecosystem. Take a look at the full newsletter for updates to projects hosted under the Rust OS Dev GitHub organization, as well as updates to personal projects also related to Rust OS Dev. Like last week, and I think like most weeks going forward, the Learning section has by far the most articles. Ferris Systems has published the first in a series of posts called Learning Rust, Mindsets and Expectations. This series will cover patterns for learning Rust effectively. These patterns are based on interviews with many different Rust developers about how they learned and found success with Rust. In the article's own words, give some time to your learning process and you'll see that core concepts like ownership and borrowing deliver joy. They make it easy and comfortable to write programs that are memory safe. Speaking of memory safety, Tiemoko Balo has published Blue Team Rust, What is Memory Safety Really? Balo explores what safe means on a technical level. This includes going over what exactly Rust's memory safety guarantees are, including stack protection, heap protection, references always being valid, and variables initialized before use, and data races being completely eliminated. There are some caveats when discussing memory safety in Rust. In particular, not all Rust code is memory safe. Memory safety guarantees apply broadly, not universally. Unsafe Rust code drops memory safety guarantees for a limited scope and doesn't eliminate all checks. Additionally, interior mutability can push borrow checks to runtime. To quote the author, memory safety is not a new idea. Garbage collection and smart pointers have been around for a while. But sometimes it's the right implementation of an existing good idea that makes for a novel great idea. Rust's ownership paradigm, which implements an affine type system, is that great idea, enabling safety without sacrificing predictable performance. In a previous issue of This Week in Rust, we featured an article on packaging Rust applications for Windows by Ryan Gorup, founder of Ebflow. Gorup has now followed up with a new post that covers how Ebflow packages its Rust applications for Linux. The article is broken up into problems that Ebflow needed to solve after the core code for their client was written. These problems included figuring out how to run a daemon in the background, which was solved by creating a systemd service and including a systemd unit file in the compiled packages. These problems also included statically linking dependencies using a musil target with rustup and using Russells. Finally, they also had to develop different packages for different Linux distributions. They used cargo deb to create deb packages and cargo rpm to create rpm packages. There will be another post from them in the future on automating builds and vending those builds to users. One of the most fascinating articles to me in this week's issue is reverse engineering a USB device with Rust. Harry Gill, the author of the post, was building a new workstation with the AMD Ryzen 3950X CPU and trying to get the maximum performance out of it to reduce Rust compile times. Gill used a Corsair H150i RGB Pro XT AIO to cool the new computer. It was working well until they discovered that Corsair does not provide any support for Linux, which meant Gill could only adjust settings for and view the status of cooling through Windows. Not to be deterred, the article goes on to describe how they researched USB protocol and used tools like USB PCAP to capture packets being transmitted between the cooling unit and the PC. Next, Gill created a Rust project to read information from, configure, and send commands to the cooling device from Linux. This is a really cool project and a great introduction to reverse engineering USB devices. One of my favorite ways to learn and practice new programming languages, or refine my technique with known programming languages, is through Exercism.io. Exercism.io is a site where anyone can download exercises for various programming languages. Then they can solve the exercises and submit them back up to Exercism, where they can then receive mentorship on their solutions by volunteers. One of the challenges of Exercism is that it can take some time for a live person to get around to reviewing a submission. Sean Chen, a contributor to Exercism.io, describes this problem and a potential solution in the blog post titled "Some Learnings from Implementing a Normalizing Rust Representer." Chen wanted to decrease wait times for students by streamlining the feedback process for Exercism mentors. One thing Chen realized would help would be normalizing the submissions by stripping away things like formatting, comments, and variable names so the mentor could focus on the logical approach of the submission. Chen created a Rust normalizing representer that parses the source code of submissions into an abstract syntax tree, then applies transformations to the appropriate tree nodes, and finally turns the tree back into a string representing the transformed source code. See the blog post for more information about the implementation of this normalizer. To me, it felt very similar to how the Rust compiler works. My other favorite way to learn and practice Rust is through the Rustlings exercises. Rustlings is a collection of small exercises to get you used to reading and writing Rust code, including reading and responding to compiler messages. Chris Biscardi has put together a series of videos that show them working through the various Rustlings exercises. I have been through all of the Rustling exercises myself, and there were 2 or 3 that I could never fully figure out the answer to. I'm looking forward to watching and learning from the videos on those exercises. Moving on to project updates. The Rust language cheat sheet, also known as cheats.rs, is a project from GitHub user Ralph Bierdert. It is a single-page Rust resource for people who like high information density. Ralph Bierdert has written up a status update that details changes to the project from 2019 to 2020, including a complete rewrite of the memory and lifetime section, the addition of a visual section, coding guides, and much more. Under the miscellaneous heading in this week's newsletter, we feature 2 episodes of the Virtual World podcast. The Virtual World podcast by Ty Tracy is a podcast about software engineering, technology, VR, art, music, creativity, inclusivity, and love. This week they posted 2 State of Rust episodes, one with Alex Crichton and one with Steve Klabnik. Moving on to RFCs. One RFC was approved this week, the C Unwind ABI. It has been exciting to watch the progress of this RFC from its very beginning to its acceptance. We've covered this RFC on previous episodes of this podcast. Please refer to those episodes or to the RFC itself for more details. 2 new RFCs were proposed this week. The first, titled Edition 2021 and Beyond, revises rules and plans for Rust editions. It announces plans for Rust 2021 edition and for a regular cadence of editions every 3 years. In the RFC's own words, unlike Rust 2018, we will avoid using editions as a deadline to tie together high-priority projects. We specify a cadence for edition lints. We specify a policy on reserving keywords and other prospective changes. See the full RFC for all the details and discussion. The second new RFC is titled Procedural vtables and Wide Pointer Metadata. To quote the RFC's summary, building a wide pointer from a concrete pointer, and thus vtable generation, can be controlled by choosing a custom wide pointer type for the trait. The custom wide pointer must implement a trait that generates said wide pointer by taking a concrete pointer and a generic description of a trait impl. By default, if no vtable generator function is specified for a specific trait, the unspecified scheme used today keeps getting used. Now let's discuss upcoming events in the Rust community. Are you feeling nostalgic for travel? Over the next 2 weeks, you can take a trip around the world through online Rust meetups, including in Johannesburg, South Africa, Dublin, Ireland, Linz, Austria, Berlin, Germany, Saarbrücken, Germany, Buffalo, New York, Indianapolis, Indiana, Seattle, Washington, and San Diego, California. Enjoy your trip! Additionally, an in-person meetup is currently scheduled in Columbus, Ohio. And that's it for the summary of This Week in Rust, issue number 350. Now let's move on to interviews with some of the RustConf speakers. Our first interview is with Siân Griffin, who will be presenting the closing keynote of RustConf. Siân, well, could you introduce yourself for our listeners?
Yeah, my name's Siân Griffin. My pronouns are they, them. I've been working in Rust for, I don't even know how many years now. I co-lead the Crates.io team, and I'm also a member of the infrastructure team.
Awesome. We're glad to have you on the show and very excited about hearing you speak at RustConf coming next. What's the topic of your talk?
So my talk is about the missing no glitch from Pokemon Red and Blue. We're going to look at all of the really technical details of why it happened and the constraints the developers of those games were working under, and why I think if you were working under those constraints, you would have introduced the exact same bug.
Absolutely. We were talking a little bit before this, and I mentioned my dad, who's an Air Force pilot, used to say whenever he was analyzing an accident, after analyzing it, there, but for the grace of God, go I.
Yeah, I mean, it's just insane, the constraints that game developers had to work under in the early 90s. I mean, this was when folks were still handwriting assembly, and your whole program had to fit in 8K.
Right, so this is an original Game Boy, it sounds like, if it's in the 90s era.
Yep, original Game Boy. The follow-up which fixed this bug was Pokemon Yellow, which was on the Game Boy Color.
Gotcha. And what drew you to this topic?
My partner and I have both been big fans of Pokemon our entire lives. And I really enjoy watching speed runs of video games, and there's a lot of speed runs of the original Pokemon games because there are glitches all over the place that you can exploit to finish the game really quickly. Yeah, so as a kid in the 90s, we all knew about the missing no glitch. It was a really useful thing that just somehow managed to spread across the entire, at least the entire country. I assume the entire world, but I can't speak for folks who grew up outside the US what their experience was. But yeah, so as an adult, I was curious, like, so why did that bug even occur? It was such a, like, why did encountering this Pokemon, it was such a seemingly random sequence of events you have to do to cause the glitch to happen, and increasing the item count of the 6th item in your inventory was just such a weird side effect of encountering a Pokemon. I really wanted to know why it happened, and when I started to learn all of the details of what goes into it, I just realized, oh, yeah, no, that it's absolutely reasonable that would have slipped through. And so I kind of wanted to give a talk of just like, hey, maybe we should stop saying things like oh, this software is so broken, because usually it's just under constraints that we don't understand.
Yeah, I'm trying to remember. I'm just thinking about the constraints that game developers in the 90s would have been under, not just the time, crunch time that we hear about in game development today, but also the restraints of compared to, your x86 computers today, a very constrained system in the Game Boy.
Well, and it's also, at the time of the original Pokemon, Game Freak was a really small company. This was their first large-scale game. It was relatively rushed out in Japan. If you look at the sprites for Pokemon Green, you can definitely see like the massive difference in quality between Green and Blue. And for Blue, I mean, it was unexpectedly popular in Japan, and they had to rush out a US release, and that's where a lot of this stuff sort of slipped in.
Awesome. So you covered this a little bit, but just getting a little more specific, what can our audience look forward to seeing in your talk at RustConf? Because you're their closing keynote.
Yeah, so I mean, this is going to be a really in-depth technical look at the assembly of the relevant pieces of the game. What it looks like in Rust, don't worry, you do not have to be well-versed in Z80 assembly in order to enjoy this talk. You also don't need to have played or even heard of Pokemon before. We're going to go over all of this, but we're basically going to be looking at what actually happened under the hood at each step of the bug, why the developers may have made the choices that they did that led to the bug happening, and basically just try to understand why is it that if you talk to a dude who catches a Weedle in one city and then surf up and down a coast in another city, you run into a glitched Pokemon and get 128 rare candies.
Awesome. Well, I certainly look forward to seeing your talk. RustConf is virtual this year. If it was physical, I would say, well, let's have a Pokemon Go party afterward. But we can have we'll figure something out. Well, thank you so much for joining us, Sean, and I can't wait to hear your talk.
Of course. Thanks for having me.
Could you introduce yourself for our listeners?
Yeah, so my name is Shane Lusby on GitHub and Twitter. My tag is YawC, and I am just a Rust fangirl who really likes error handling.
Awesome. And what's the topic of your talk?
My talk is about error handling. Specifically, the talk is titled "Error Handling Isn't All About Errors," and I'm going to try and get into some of the details of error handling, and specifically errors versus context versus error reporting, and kind of separate these ideas in a way that makes everything easier and simpler to understand.
I know as Rust developers, whether they're new or experienced, a lot of us don't want to deal with error handling, so we just copy and paste stuff that we think works into it, but we don't really understand how they work and how we can use them to make our code the best they can be. And what drew you to this topic?
It's actually, it was a yak shave. I was trying to open source this little tool I'd written for work. And I ended up, before I open sourced it, I was kind of embarrassed by the error handling, because I'd kind of just copied and pasted and tried to sweep it under the rug so I could get the actual work done. And I really wasn't happy with it. And so I decided to try and fix it before I open sourced the project. And ended up getting lost completely in the world of error handling, and now it's just kind of my favorite thing about Rust.
All right, what can our audience look forward to about your talk?
Hopefully you can learn some useful patterns and some cool libraries that you can use to easily do proper error handling from the start.
Awesome. Well, I'm looking forward to that talk. I think you're first up right after the core team keynote. So I didn't mean to make you nervous there.
No, it's cool. I had a gasp, but then I'm like, wait, it's recorded. I'm not going to actually be nervous.
We are pre-recording them. Yeah. So very much looking forward to your talk and looking forward to chatting with you in the Discord server at RustConf.
Yes.
Finally, for this week, we also spoke to Ashley Hauck, who will be presenting controlling telescope hardware with Rust. All right. Well, Ashley, welcome to our podcast. Could you introduce yourself for our listeners?
Hi, my name is Ashley Hauck. I'm a developer at a game studio called Embark Studios in Stockholm. I've been interested in space since I was a kid.
How long have you been doing Rust?
I've been doing Rust for a couple of years now, probably around 4 or 5 years, I think. I've attended RustConf starting in 2017, I think. Yeah.
Great. Well, what's the topic of your talk?
So I'll be talking about telescopes and how they work, and especially how to control a custom hobbyist telescope with Rust. And so I'll be talking about the hardware and how we talk to that hardware using serial ports, using C APIs. Yeah.
Sounds like it's going to be covering a lot of ground.
Yeah, it is. It's mostly an introduction of hardware. So if you're like a super Arduino hacker or whatever, this will mostly be over you. But if you want to get an introduction of how to start in the world of hardware with Rust, this is the talk for you.
Awesome. What drew you to this topic?
I've been interested in space since a kid. I think it grew out of a passion to be an astronaut. Like every kid wants to be an astronaut. And that passion sort of morphed into a passion for astronomy. And so I got into astrophotography a couple of years ago. And I bought a telescope, bought all of the hardware, and started taking pictures of the sky. And I slowly realized that I wanted to customize my telescope quite a bit. And so I developed an application to control all of my telescope hardware in Rust. And I wanted to share all of my experiences of developing those hardware controls in Rust.
Sounds great. Next question I'm going to ask is, what can our audience look forward to about your talk? But I think I want to preface that with, will there be pretty space pictures?
Yes, there will be pretty space pictures in the talk.
That's right. And it sounds like there's going to be pretty space pictures, and also it's going to be a good introduction to hardware hacking, which I know there's a lot of interest about.
Of course, yes.
Thank you. Well, I am looking forward to your talk. I know our listeners are too, and we will see you at RustConf.
Thank you so much for having me.
As a reminder, RustConf registration is open, and I hope to see you all there. Make sure to listen next week for more interviews with the upcoming speakers. And that's all for this week's podcast. Make sure to check out the full issue of This Week in Rust for even more fantastic Rust content. This Week in Rust is edited by myself, Andre Bogus, and Colton Donnelly. This week's contributors included, using their GitHub usernames, Gorup, LNF3, Darnius, Emor, Ralph Bierdert, Merrick G, Epolis, Daniel Liu Codebot, Shino Kada, DNS2UTF8, Inshalayas, TN Ballo, and PNEHRER. As always, if you write a great article on Rust or happen to see one, please submit it to This Week in Rust by opening a pull request on our GitHub repo. Have a wonderful week, everyone, and please stay safe out there.